Hello, hopefully you're doing well today. This is going to be our reminder of how to simplify square roots. We're going to start with our list of perfect squares, 1, 4, 9, 16, 25, 36, so on and so forth. This list goes on forever. Why do we need to be familiar with these numbers? Because these are the numbers that when we take square roots, we get nice whole numbers out. The square root of 121 is 11. Notice the square root is gone. Just 11. When you take the square root's gone. What happens when you take when you take the square roots of a number, say like 120? If you type it in your calculator in a TI-84, it's going to tell you 10.95. Blah, 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 blah. That does not have a nice whole square root number, but there are things we can do to find a simpler way, shouldn't maybe say simpler, a way to write this with smaller numbers that we'll consider to be simplified. It is all starting with these perfect squares. So we look at a number, say like 50. Just like we do with factoring a little bit, we think about what numbers multiply to 50. So what are its factors? 1 and 50, 2 and 25, 5 and 10. Now of this list, how do we choose which list pair that we want to use? We're going to look for the perfect square. On this list, that perfect square is 25. So we can think about the square root of 50 as the square root of 25 times the square root of 2. And the square root of 25 has a nice square root. It is 5. So square root of 50 is equal to, they have the same value as 5 square root of 2. Our calculator will tell us the same thing. The square root of 50 is 7.07106, blah, blah, blah. And if I were to type 5 times the square root of 2 and I press enter, you'll notice they are identical. They're the same thing. One is just our simplified version. Now, 2 more examples before we get to some that you're not going to see some answers for. 216. This is a bigger number. And again, how do you come up with a list like this? Please notice 1, 2, 3, 4, 6, 8, 9, 12. If you're not good at coming up with this, you can use your calculator to divide all the numbers as they get bigger. Divide by 2, divide by 3, divide by 4, divide by 5. If you see any decimals, you don't include it on our list. There's something interesting about this problem, though, is that if you'll notice our list of factors, 4 is a perfect square, 9 is a perfect square, and 36 is a perfect square. So maybe you started with 4 times 54. 216 square root, we can think about it as the square root of 4 times the square root of 54. And the square root of 4 is 2. 2 times the square root of 54. Now you might see this answer over here. The answer is supposed to be 6 square root of 6. So why does using this perfect square of 4 not give us this answer that's boxed over here? Well, if you take a look at my calculator part screen again, here's something to notice. If I do the square root of 216, we get 14.696938. If I do, not 4, 2 times the square root of 54, you'll notice identical. But you'll also notice if I do 6 times the square root of 6, all 3 of these are the same. All 3 of these things are equal. But here's the problem. There's only one of them that is the most simplified. Six times the square root of 6 is the most simplified. So how could you do that with 2 times the square root of 54? Well, if you kept going, square root of 54, 54 is 9 times 6, with 9 being a perfect square. Here's another way you can see that 6 root 6, square root of 9 is 3. 2 times 3, not plus. 2 times 3 is 6. 6 square root of 6. You can see that we can get to our final answer. But how do you save yourself having to do this twice. Do like the same type of steps 2 times in a row. Well, my hint to you is instead of finding your factors of 216, kind of just going through all the numbers, my advice is going to be take your list of perfect squares. You start from the bigger end. You cannot read that word big, I'm sorry. You start from the bigger end and you start dividing the number you're trying to simplify in the square root by these numbers. And one other hint to let you know. You never have to think about numbers bigger than half of this number. So if you didn't know this list of factors, here's what I would tell you to do. I would first tell you, think about what's half of 216. 216 cut in half is 108. I'd then look at my list of perfect squares, and I'd choose the number that either is this or is one less. Or not one less, just less in general. So I would start with 100. Now I'm hoping you would know that it's not divisible by 100, but I'll show you that I checked anyway, so 100 doesn't work. And then I would divide by the next perfect square. Not every number down in a row, but by the perfect square. I'm still getting a decimal. Still don't want it. 216 divided by the next one on our list is 64. And you'll notice, started with the big numbers and getting smaller. 64 doesn't work, so we would try the next one in our list, which is 49. We get a decimal, so that doesn't have a nice, they're not nice factors. 216 divided by what's after 49, 36. If you do it this way, you are going to run into the biggest perfect square that is a factor of this number, so you'll only have to do this simplifying step once. All right, now one last thing. Not all numbers inside of square roots can be simplified. If you think about a number like 34, it is not divisible by any of these perfect squares. If you used my thought process, if I divided by 2, that's 17. So I'd start with all of the numbers smaller than 17 to see if it divides into 34, besides 1. 34 divided by 16 is a decimal. 34 divided by 9 is a decimal. 34 divided by 4 is a decimal. It's not divisible by any of these perfect squares, so we would not be able to change the way the square root of 34 looks. That is already simplified. Now, some more examples. Let's go through them if you need me to walk you through them. I look at 20. Half of 20 is 10. So I know the only numbers I need to check if it's divisible by for our perfect squares list is 9 and 4. 20 divided by 9, that's a decimal. 20 divided by 4, that's 5. So we can break up the square root of 20 into the square root of 4 times the square root of 5. And why do we do this? Because the square root of 4 can be simplified. We can take that out of a square root. The square root of 4 is 2. So the square root of 20 and 2 square root of 5 are the same thing, with 2 square root of 5 being the simplified answer. You could always use your calculator to double check that you didn't simplify anything incorrectly. You should always see the same result if all you're doing is simplifying, not solving. If all you're doing is rewriting the way it looks, it needs to have the same value. For 75, half of 75 is going to be 30. We'll call it 38. So all the numbers less than 38, those are the ones you have to check. Now, if you don't know, 36 divided by, said that wrong. 75 divided by 36, decimal, don't want it. 75 divided by the next perfect square in our list, which is 25, 25, and 3. So square root of 75 is the square root of 25 times the square root of 3, and square root of 25 is simplifiable. Square root of 25 is 5. So our simplified answer is 5 times the square root of 3. Those check out. 2 more. Nope, 4 more. 98. Half of 98 is 49. And would you look at that, 49 is on our list. That's always nice. So 98 is 49 times 2. So the square root of 98 is the square root of 49 times the square root of 2. Square root of 49 is simplifiable. 7 square root of 2. 108. Half of 108 is 54. So we take all the numbers less than 54. 108 divided by 49. Decimal, don't want it. 108 divided by our next perfect square, which is 36. 108 is 36 times 3. So we're going to break that down to the square root of 36 times the square root of 3 and the square root of 36. Oh, I was trying to highlight there, my bad. Square root of 36, that is simplifiable to 6. So square root of 108 and 6 times the square root of 3 are the same. 6 square root of 3 is the simplified version. Two more, some big numbers. 468. You take half of that, and we're at 234. You might notice this list at the top of this slide does not go maybe far enough for the numbers we might have to check. You might have to think about 11 squared, 12 squared, which I was just about to write incorrectly, 144, 13 squared, 14 squared, 15 squared. 225 is 15 squared. That is the number that's going to be right under 234. So if you don't know what divides 468 and you want to have a specific list to check, well, here are your list of numbers. 468 is not going to be divisible by something that ends in a 5, so I'm going to start with 196. Doesn't work. 468 divided by 169 doesn't work. 468 divided by 144 doesn't work. 468 divided by 121 doesn't work. 468 divided by 100 I know is not going to work. That's not possible, so I'm going to move on to 81. Doesn't work. 468 divided by what's after 81? 64. Still not there. 468 divided by 49. Nope. Divided by 36. Oh my goodness, finally. So 468 is 36 times 13. We like 36 because that has a nice square root, so our simplified answer is 6 times the square root of 13. That one took a little bit to figure out. 132. Thank goodness that's a little bit smaller here. We divide by 2. We're going to start with all the numbers less than 66, which means we're going to start at 64. 132 divided by 64. Decimal. 132 divided by 49. Nope. 132 divided by 36. Nope. 132 divided by 25. I know that won't work. Something that ends in 5 is not going to divide into something that ends in a 2. Divided by 16. Still nothing. 132 divided by 9. Still a decimal. Divided by 4. 4 times 33. Yikes. All the way to the end there. Oops, not 32. 33, pardon me. We can take the square root of 4, so we can only simplify the square root of 132 into 2 times the square root of 33. So, hopefully that is a good reminder and maybe a way, if you've struggled with this in the past, to kind of give you some steps you can take to simplify radicals. Thanks for watching.